Welcome to a video on rate of change. So we've had a long look at differentiation and considered the different ways we can differentiate. But we're also looking at this video that differentiation can also mean rate of change. So for some practical situations, we have some quantity that can be written as a function of time. And when you differentiate with respect to time, you'll get the rate. And that's the rate that it changes over that time. When we mention instantaneous rate, we are talking at a particular time. So it's the derivative at that time t. So what we'll do is sub in t and find out the rate at that time. Note, this is different from average rate, and we can use that using the formula Q2 minus Q1 over T2 minus T1, which finds us the average rate. So we're going to look at a mice plague that's hit town. The council wants to deal with it, and the estimate amount of mice is represented by 8 plus 7t minus t squared, where m is in millions and t is in months. And we're going to find the initial population and the initial rate. We're going to find out when the rate stopped increasing, and we're going to have a look at when the mice population was 0, and then sketch the graphs at the end. So when we say the word initial means when t is 0. So we can sub 0 into that initial population, and we find out that there were 8 million mice initially. To find the rate, so we differentiate. So dm dt, so differentiating m with respect to t, we get 7 minus 2t. So the initial rate, when t is 0, is 7 million mice per month. When did the council stop the rate? Well, the rate is the first derivative, so stop means equals to 0. So we allow 7 minus 2t to equal to 0, and solving it as an equation, we get 3.5 months. When was the mice population equal to 0? So no mention of the word rate, so we're just focusing on the mice population. So we let 0 equal to 8 plus 7t minus t squared. Factorise that as a quadratic, and you get 8 minus t and 1 plus t. Solving those equal to 0, you get time is 8 or negative 1. Now we can't have negative time, so the mice population was 0 after 8 months. And all of this can be seen in a sketch. So you can see that with our first sketch of M, the initial population is 8. The highest it gets to is just over 20 million after 3.5 months. And we saw that. That's where the population rate stopped. And there is 0 after 8 months. And we can see that down on the bottom axis. With the dm dt, that was 7 minus 2t. And so the initial rate was at 7, and you can see that is at 7. And it stopped after 3.5, and you can see at 0 on the axis, it crosses at 3.5, and it continues down because it starts to decrease. So all the first rates are positive, and then at 3.5 it's 0, and then after that it is negative. And finally, introducing 3 new words: increasing, decreasing, and stationary. So increasing is when the gradient, or y dash, is greater than 0, or the differential is greater than 0. Stationary is when y dash, or the differential, is equal to 0. And decreasing is when y dash, or the gradient, is less than 0. Thank you.